and we were planning on doing cabinets, and we thought of you, but we never did cabinets.
Oh. All right, guys, here we go. Did you say huh?
What?
Oh, I should have put what. Okay. You guys ready? So example 1 is pretty much stuff that you guys already know. That's just U sub. I did put some of these questions on delta. This is really one is coming from delta. I think it's coming from delta. Let f be a function such that write an equation that can be inferred involving the integral of the function f of u. All right, and then they have here on the right-hand side the box of what is f of u du. So let's just see. So the way it looks like I'm going to make my u equal to 1/3 x squared minus 5. And I see that because, well, I'm like, okay, well, I guess that has to be the u there. And then the du is 2/3 x dx. Have I confused anyone? Okay. So what I'm going to do, I guess let me rewrite the integral. Integral -6 to 0. So it's just the original. And in a little bit, I'll switch colors to indicate what I'm adding to this. All right. This has a summation of 6. You guys can come in. Just go over there. So this has a summation of 6, guys. So I know that whatever I get in terms of u, it's going to still equal 6. So what do I need? I need a 2/3. So I put a 2/3 right here. See that 2/3 x dx? So if I put a 2/3, I got to put what on the outside? 3/2. And I think I'm ready. I think that's all we need. So here, let's see. 3/2 integral f of u du. I need u limits. When x is 0, yes. Yes, because I need that to balance, right? I need that to equal 1. When x is 0, u is -5. And I know, Chubb, you usually go the bottom first. I usually do. For whatever reason, I did the top one first. The top.
So, because I assume that the parentheses 1/3 x squared minus 5, right? That's all like a function.
It is a function.
Then how come multiplying? Oh, okay, never mind. Wrong thing. Okay, got it.
When x is -6, ooh, I'm going to have to do that one. 1/3 -6 squared minus 5. 1/3 times 36 minus 5. 3 goes into 36. Is it 12 times? And then 12 minus 5 is, so I'm going to put a 7 in the bottom here.
Like 6, 7.
No. Okay, now all this, I haven't done anything, guys. It should be the same value as my top integrand. So all this still equals.
So, like a 6, 7.
No, that's 6. 6 7. 6 7.
Whoa.
Sorry. All right, here we go.
That's how you guys 6, 7.
Yeah, relax. I'm not talking smack. Yeah, I'm not making fun.
Why? Mickey always wants to make fun.
Yeah, I'm not making fun. All right, here we go. I want f of u. I want the integrand from a to b of f of u du by itself. So all I got to do is get rid of this 3/2. So I do that by going, and whatever I do to one side, I do to the other. So here's what I finally get. I get integral from not negative, but just 7. From 7 to -5 of f of u du equals, let's see, 3 goes into 6 twice, and 2 times 2 is 4. So there it is. I come over here, and I say my lower limit is 7. My upper limit is -5. And the integral from a to b, which is those limits of f of u du, is just 4.
So we don't need to include the 6, and so we're trying to find the value of f of u du.
Yes.
So, you don't need to, like, flip it to make it, you know, we flip the limits to make them.
You can if you want, but then that would be a -4. Are we okay so far? Miss Kyle, you doing okay? All right, here we go. Example 2. I really like this example, by the way. If g prime equals f, with g of 0 equals a, g of 1 equals b, g of 3 equals c, g of 4 equals d, express the value from -1 to 0 of x of f of 4x squared dx in terms of a, b, c, and or d. Okay, we're going to go slow. Guys, make a note It does not matter what letter you have in there. If you say g prime of x equals f of x, I could have also said g prime of w equals f of w. I could have said g prime of triangle equals f of triangle. I could say g prime of u equals f of u. It does not matter. That's it's just a function with respect to x. I can put any letter there. What's up, Houston?
So B, C, and D are basically just variables for y values and x values, right?
B, C, and D are just the y values of the g of 0, g of 1, g of 3, and g of 4. All right, you guys ready? So I want to know this integral, negative 1 to 0 of x f of 4x squared dx. So I look at it, and here's what I should be thinking in my head. I see a 4x squared as my argument for f, and I see an x outside of that, but it's still inside the integral, but outside the function. Are we still okay? So I should be thinking, well, if I take the derivative of a quadratic, I get a linear. So your u equals 4x squared. Your du equals 8x dx. Are we okay so far? So I see this and I'm saying, okay, well, I'm going to put an 8 right here. And I put a 1/8 on the outside to balance. Does that make sense to you guys?
Yes.
Okay. So now I'm ready to rewrite this. 1/8 integrand. I'm going to put my limits last. That's a 0 on the top, right? Yeah. So let's see. 8x dx is du. Put that last. F of u du. Yes.
Integral or integrand?
Or you can use them interchangeably. The symbol itself, if it's just singular, integral. But if I have stuff like, the integrand. All right, you guys ready? When x is negative 1, negative 1 squared is 1, and 1 times 4 is 4. When x is 0, 0. I mean, you could if you wanted to, but I'm going to leave it alone for now. Are we still okay? No, not always. It depends on whatever you have. It's ideal, but it's not. You don't have to. Are we okay so far, guys? All right. Notice that what I have up here, look at this right here. I can rewrite this and write it like this. 1/8. Look what it says. F of u is equal to what? Integral 4 to 0 of g prime of u du. Are we okay so far? What's up, De Leon? Tell me. Oh, are you sure? Yeah. Okay. Here's my 1/8 bracket. What's the antiderivative of g? What's the antiderivative of g prime? G. 4 to 0. Are we still okay? All right, here we go. 1/8 bracket g of 0 minus g of 4. Do I know what g of 0 is? A. So 1/8 a minus, what is g of 4? So this will be a minus d over 8. What's up? I don't know what you're talking about.
Like we didn't have to do the g of 0 against g of, I think we did g of 0 minus g of 4.
Well, it was asking different things. This one was asking for the integrand. See, right there. So, but on this one, it was asking for me to solve it in terms of A, B, C, and D. So it wanted me to do upper minus lower. That's the only way you can incorporate A, B, C, D. All right, guys, you guys ready? You can already see what's coming from UH. Please do the UH honest, like be honest with the UH, especially the test for UH, because to me, I just, if I see everyone doing well, I just assume everyone knows what's up, so I just continue to amp up. So be honest, because I don't know what you're weak on unless you're being honest. Okay, we're ready, guys? So from UH, and I put this one in here on purpose because in years past, kids have issues with this one. The A is a constant. I look at it and I say, okay, well, I see a linear expression on the outside of that square root. I see a quadratic on the inside. Hey, no, your name is Kyle. I saw you. You think I didn't see it, but I saw. A squared minus x squared is my u. So your du, the a is a constant, negative 2x dx. Are we okay with that? Okay, everything in red just means that it's the same. So I'm going to put this 3 on the outside. I haven't done anything yet, guys. It's a constant. 3, let's see. I haven't done anything yet, guys. So I'm still putting the same limits because I have not changed anything yet. A squared minus x squared dx. What do I need inside the integrand? So here's my negative 2 that I'm adding. So look and see different color. And if I put a negative 2 on the inside, I got to put a negative half on the outside. So there it is, my negative half on the outside. I put it below the 3. Do you guys see what I did there? Okay. So we're going to go slow. So now negative 3 over 2 integral. It needs new limits. I'll put them in a little bit. Square root of u du, because there's my negative 2x dx. Make sure to put the du in the end and not in the beginning. When x is 0, plug it in right here, u is a squared. When x is a, u is 0. Yeah, look, yeah, now I'm going to flip. See, guys, when you plug in an a here, what's a squared? Well, what's a raised to the power 2? And a squared minus a squared? 0. This is a good candidate. This is a good candidate to flip the limits. 3 over 2 integral 0 to a squared. And instead of saying square root of u, I'm going to say u to the half. Du. Yes. So I can have a positive on the front. Algebra, maybe it makes it easier, maybe it not. It just depends on how you view it. Because easy is relative. Okay, you guys ready? All right. Here's my 3 over 2. That's that one. I'm going to put a little dot because I'm going to be multiplying. Antiderivative of u to the half. Add 1. U to the 3 over 2 divided by 3 over 2, which is the same thing as. Do you guys see that? Put a line. Put a 0 on the bottom. Put an a squared on the top. So catch up to here. Notice. Bam, bam. Do you guys notice that? All right, here we go. I'm just doing upper minus lower. I guess you don't really care about the 0 because 0 to anything is 0. So I'm going to have a squared raised to the power 3 halves. Chop, how do we do that? We'll figure it out right now. 0 to the power 3 halves. Here comes algebra. When you have an exponent raised to an exponent, a to the third. When you have an exponent raised to an exponent, you multiply them, guys. I'll do a side note for those of you that want the proof of that. So look, a squared, this is just a side note. It's not anything to do with that. That means you got 3 of them. A squared, a squared, a squared. See? Where'd it go? Okay, right here. A squared. And then look, well, that means you got 2. A times a times a times a. Oh, look, how many a's do you have in there? A to the 6. So what do you do when you have an exponent to the exponent? You just multiply them. And that's law of exponents from your algebra days. Cool or not cool? Cool. All right. Here's another one. This is kind of similar to what you have in your circuit. The worst answer, there's 2 of them on this one. So when you look at this, you're like, what is it going to be? Especially if it's a multiple choice answer. The worst one is arc sine. Why? Because the antiderivative of arc sine has square roots in it. You guys remember that? So those are the worst answers. So now, what are you going to do? Well, look, focus on this. Make it look like this. 1 plus 6e to the x squared. Chop, how does that help me? Yeah, look, by the way, does anyone have issues with this? Or I get it. They're like, Chop, how was I supposed to know that? With experience, you start to get better at this. So this is why it's so important to not rely so much on AI. So maybe the first time, maybe, but after that, like, oh yeah, this looks like this. So iteration is key. Like practice is key. The more experience you have, the better you'll be. That's pretty much true for everything in life. You just need experience for whatever it is, and you'll get better. Want to be a better basketball player? Practice. Want to be a better runner? Practice. Want to be better at whatever? Practice. What's up?
So then essentially, would it be like, in order to start solving, you would be, yeah, and so then you would either plug in a 6, and then on the outside it would be 2 6.
Yes.
So can we automatically from there say that's
Yeah. So my u is going to be 6e to the x. So here's what Cruz was trying to say. If you make u equals 6e to the x, my du is 6e to the x dx. And look what happens, guys. There it is. There's my e to the x dx. All I'm missing in the top is a what? So if I put a 6 there, what do I put on the outside? There it is. Whatever is color-coded is what I'm putting, brand new. 1/6 integral. 6e to the x dx is just du. And then 1 plus u squared. Now, hopefully, that looks easier for you guys. Let me rewrite it. 1/6 integral 1 over 1 plus u squared with my du on the side. Now, hopefully, you can see that the antiderivative of that is just arctan. Arctan of u squared. Of u, sorry. Just u. And there it is. Do I have any limits? No, I don't. Plus c. And then plug back in what u is. Why did I say u squared? That's so weird. I wonder what I was thinking. There it is, guys. What's the answer? And don't worry, I know some of you had questions with the circuit. We'll bring that up in a little bit. Okay. Ready for this one? All right. Why can I not do u substitution on this? Yeah. Look, check it out, guys. Well, if you were to try to do it, let's see. Look, there's nothing I can do to make, do you guys see what's going on? So du, what am I doing here, man? Sorry, guys. I'm all over the place. U equals 2x squared minus 15x plus 28. And look, my du is 4x minus 15. 4, 8, 12. Nope, there's nothing I can do to make, with a dx on the side. There's nothing I can do to make that x minus 3 equal to this. Does that make sense? There's nothing I can do about that. So what do? Well, do you guys remember long division? Relax. It's not even going to take that long. You guys make it so. No, you're not going to have a calculator for this. Bless you. Look how easy it is, guys. All I'm doing is just doing that. X minus 3, and then 2x squared minus 15x plus 28. You've done this before. I know for a fact you've done this. X times what gives you 2x squared? So I put a 2x here on the top, and I put a 2x squared here on the bottom. And then don't forget that 3. 2x times negative 3? Positive or negative? Negative 6x. I put this in parentheses. I put a minus in the front. I subtract. These go away. Minus a negative, so that's going to be a plus. Difference between 15 and 6. 9, and it's going to be a negative. Bring that 28 down. Do you see what we did? All I'm doing is long division, guys. I guess I'll do a side note. Look, here's a side note. I'll pick easy numbers. If I had 82 divided by 9, that's the same thing as doing this, like that. What did you do in elementary? You put a 9 up here, you put an 81, and then you subtract it. So this is 9 remainder 1, or 9 and 1/9. Right? It's the same thing. It's the same thing, but with letters. Okay, I have that 9x, negative 9x. X times what is negative 9x? Negative 9. So I put a negative 9x here. Don't forget that 3. Negative 9 times negative 3. Plus 27. I put that in parentheses, and I'm going to subtract, just like what you did when you were in 5th grade. See? The 9x is 0 out, and I have a remainder of 1. So I can say remainder 1, but we're in calculus, so we're going to say this. You're going to go plus 1 over x minus 3. Plus because it's positive. So I'm going to rewrite this. Integral from 4 to 6 of 2x minus 9 plus 1 over x minus 3 dx. Yes.
Why did you put it like 1 over x minus 2? Like, I know that's a remainder,
Right.
Why did that? How does that represent the remainder?
Which remainder 1? But if I choose to not write remainder 1, I put 1 and then my bottom was x minus 3. Just like, look, just like what we did in 5th grade. Look, see how this one's remainder 1? 9 remainder 1, or 9 and 1, 9. I think it's 5th grade. I'm not sure. Because I was never a 5th grade teacher. But I remember that's an elementary, like dividing, right?
Oh no, I see. Like I had like the 1 over 9 with the equivalent. I never did that.
Oh, but now you do. Okay. All right, here we go, guys. This should be a lot easier to integrate. Look how easy this is. Do I have a linear expression in my fraction here without a variable in the numerator? So when I get to this one, the antiderivative of that is just going to be an ln. All right, so here we go. Antiderivative of 2x. X squared. Antiderivative of 9. 9x. Antiderivative of 1 over x minus 3. There you go. I have more than one term, so I put that in brackets, put a lower limit 4, put a upper limit of 6. Depending on who your professor is, the professor might not like brackets. I've been cool with brackets all my life, so bless you squares. All right, we still okay, guys? All right, let's just plug in, upper minus lower. So let's see, big parenthesis, 6 squared minus 9 times 6, what's that, 54, plus ln of 3, 6 minus 3, close big parenthesis, that's my top, minus, I'm doing my bottom now. Let's see, 4 squared, 16, maybe I should turn that into 36, oh well, that's fine. Minus 9 times 4, what's that, 36? Plus 4 minus 3, that's ln of 1. Yeah, ln of 1 is 0. All right, here we go. So I have, this is 36 minus 54. What's that? 36, 46, 56. So negative 18 plus ln of 3. And then 16, 26, 36. This is negative 20, right? But when I distribute the negative, it's going to turn into a plus 20. And then ln of 1 is just 0. Plus 0. So let's see. So my final answer, 2 plus ln of 3. Try to do this without calculator assistance because you're going to have to be pretty good at arithmetic. What's up? Said it? This one? Oh, ln of 1 is 0. Why did I distribute one negative? This? Oh, because I'm surprised. It's this minus this. This was already negative 20, so I distributed the negative to that negative 20 to make it positive 20.
But she's asking like you put positive 0, but it should have been negative 0.
Oh, it doesn't matter. 0 is 0. So, yeah, you're right. Okay. 0 is 0, but in my brain, I should have written minus 0, but 0 is 0, so it doesn't matter. Yeah, maybe I should have been minus 0. Let me change that to a minus. Sorry. Yeah, it doesn't matter. It's 0, so if I see 0, I don't care about it. All right. Are we okay with that, guys? All right. Chav, what about this one? You can't do U substitution either. So, Chav, I can't do long division with that. Yeah, you can. You can do long division with anything. It's just going to look weird. But this one's not going to look weird. The x plus 8 is in the bottom. X times what is 2x? I put a 2 on the top. I put a 2x in the bottom. Don't forget that 8. 2 times 8 plus 16. Put that in parentheses. Put a minus in the front. These zero out. 17 minus, bless you, did someone say? 17 minus 16 plus 1, positive 1.
So,
yep. I rewrite it, integral, negative 7, e minus 8. Child, this is going to be complicated. No, it's not. Give it a chance. Antiderivative of 2. 2x. Antiderivative of 1 over x plus 8. Yep. Bracket, negative 7, e minus 8. I'm doing upper minus lower. I'm going to go slow. Here it is, upper minus lower. Giant parenthesis, I'm putting it in blue for my top. And I'm going to go 2 times e minus 8 close plus ln, absolute value. E minus 8 plus 8 is just going to be e. Yeah, it's just 1. Minus, now I'm doing the lower, 2 times negative 7. Negative 14. When you distribute, it's going to be positive. And then ln of negative 7 plus 8, that's going to be ln of 1. And ln of 1 is just 0. So here we go. Let's see, what should I do? Distribute. So I'm going to have 2e minus 16. And then ln of e is plus 1. Plus 1. That's the top. Plus, that's a 0. Plus 14. Oh, you're already getting all the answers. 2e, let's see, that is negative 15 plus 14 minus 1. There it is, 2e minus 1. All that for that. Yes. That again? I didn't hear you. Oh, you're good? It's absolute value. All right. There's no multiple choice there on this one. Do you think it's an arc? Do you think it's an inverse trig? Probably. I see a square root. It's probably an arc sine. You can actually also say arc cosine because of the negative, but it doesn't matter. It doesn't matter. All right, check it out. I'll put it here on the side of what we should be looking at, ddx. Let me write ddu so we can do chain rule. ddx, and I'll put a u in there. ddx of arc sine of u, that's 1 over square root of 1 minus u squared du dx. So here's what I want. What do we want? You see that 1? I want that 25. It's not an ugly number, but I want that 25 to be a 1. So you're gonna have to use a little bit of algebra. Relax. So look, I'm just taking this out without the integrand. Negative 3 over square root of 25 minus 9x squared. Let me write the square root like that. So if I want to get that 25 to be a 1, what do I do? Divide by 25. Divide by 25. Divide by 25. You got to do that to everything. Divide by 5. Oh, why 5?
Oh, because square root.
It's a square root, guys. What's the square root of 25? So I have to divide the numerator by 5. That's the equivalent to dividing by 25 when it's inside the square root. Can you see that, guys? What's the square root of 25? 5. What you really did, see, it's inside the square root. So really you divided everything by 5. The square root of 25 is 5. So I have to divide the numerator by 5. So it can all stay the same expression. It's still okay or not? Come talk to me if we're not okay. Are we okay, guys? All right. Now it looks like this. Negative 3/5 integral square root 1 minus, open parenthesis, and write it like this. 3 over 5 with an x on the side, or I guess you can put it next to the 3. Close it and put a square. See, when I square it, you get 9 over 25 with an x squared on the top. Yeah, it doesn't matter. Ask me, what happened? Are we okay? All right, so here it is. I'm going to write integral. I'm going to put this negative on the outside. As a matter of fact, I'm going to put the negative 3/5 on the outside. No, not just a negative, because I'm going to need the 3/5. 3/5 square root 1 minus 3x over 5, close it squared, dx. We're okay? My u is going to be 3/5 x. Yes. That -3 is that one right there. Because remember I divided it by 5? No, keep asking. du equals -3/5 dx. Oh, maybe I need the negative. Okay. Oh, wait. Why did I put a negative there? Yeah, I don't need the negative. I was about to put it in here too. Why did I even say that? So here we go. That 3/5 dx is just what? So here's what I have. Negative integral 1 over square root of 1 minus u squared du. And relax. What's the antiderivative of this, guys? Arc sine. You can actually, well, okay. That's not, well, we won't talk about that. Arc sine of u plus c. What is my u? Negative arc sine of 3/5 x plus c. And there it is. If I were to take the derivative of that, you do in fact get this. How do we feel? All right. This one here, I don't know if we're ready for this one, guys. Do you guys want to see it? Yeah. Okay. Oh, it was on the quiz? Okay, well then let's do it. Okay, I'm going to, I don't know if it's going to reach. Okay. I'm going to rewrite this as 2 dy dx plus 3y equals 0. So do that. I'm going to move this 3y to the right. So I'm going to go 2 dy dx equals negative 3y. I'm going to leave the 2 alone. I'm going to divide by y on the right-hand side and multiply by dx on the left-hand side. I want to get all the y's together. I want to get all the x's together. So I'm going to treat the dy dx like a fraction. So times dx and divide by y. So here's what I have. Yeah, this is why I said I don't know if we're ready for this, but here we go. So I have.
So dy and y are the same. Dx and y are the same thing.
No. 2. Yeah, that's what I'm doing. Well, I'm just moving stuff around. I'm not balancing here. I'm just moving y's with the y's, x's with the x's. 2 over y dy equals negative 3 dx. Move the y's with the y's, the x's with the x's. Todd, why did you do that? Notice on the left-hand side, I have this differential dy. That's similar to like a delta y, except it's a differential. And on the right-hand side, I have a dx, which is similar to a delta x, but it's a differential. Are we still okay? If I do this to both, if I do this to one side, integrand, then I have to do that to the, and now I have something that I can mess around with. I can integrate with. What is the antiderivative of 2 over y? Yes, ln. And I guess for now, since this is our first one, I'm going to say C1. What? Yeah, because I have 2 C's. It's our first time. What's the antiderivative of negative 3? You see these two right here? If I go C2 minus C1, isn't that just still a constant? Still some constants. So that's what I'm going to do. I'm going to rewrite it. 2 ln absolute value of y equals negative 3x plus c from this. It doesn't matter because it's still some constant when you add up the constants. Are we okay? Okay, where did I lose you? Okay. All right, real quick. I just want to make sure that everyone understands that we're on the same page. This is why I wasn't sure if I wanted to do it right now. All I did was I got all the y's together, all the x's together. And why did I do that? Well, I did that because, see, when I have this differential here, the only way to get rid of that differential is to integrate. And when I integrated the left-hand side, I got 2 ln of y plus some constant. And on the right-hand side, I just got negative 3x plus some constant. And then how did the constants go away? I just added them, and I said, that is still some constant. Don't worry, I see you. Does that make sense, guys? Okay, so that's all I'm doing. From here on out, it's just going to be algebra. What's up?
So, in general, the purpose of an integral is to make a equation simpler?
No, the purpose of an integral is to sum up summations under a curve, or there's so many purposes for the integral. But in this case, to get rid of my dy, it just depends on your situation. What's up?
Okay, so now we would divide by 2 and then plug in?
No, I think I would.
How would we solve for c? If we don't have, we do have
do.
official values,
Yeah.
so then when we plug in and solve for c and then plug in -1, solve for y?
Any questions, guys? Yes.
How do you determine that the plus equals on that side?
It doesn't matter. I could put it on the left side.
Okay,
I just like to have it all the time with the x's because it's easier for me. Okay. Yeah. You can put it on the left. Doesn't matter. All right. Here we go, guys. I have this restriction right here that when x is 1, what's the y value? 6. So I always put the c's with the x's because that's all we've done all year long. It's easier for me. If you wanted to have the c on the other side, you could have. It's still going to work out. But for me, it's always better to put the c's with the x. So here we go. I'm going to plug in that 1, 6. I'm going to write 2 ln of 6 equals negative 3 times 1 plus c. Are we still okay? Yeah, it just turns to algebra. Now we're not doing calculus anymore. We're just doing algebra. 2 ln of 6 equals negative 3 plus c. I'm going to move the negative 3 to the right, or to the left, sorry. So I'm going to write it right here. C equals 2 ln of 6 plus 3. Are we still okay? Okay, I'm going to plot that c right there.
how do you get rid of the absolute value?
Because 6 is already positive. Here we go. 2 ln, and I can get rid of the absolute value because my output, the y value, was already positive to begin with. Is everyone okay? Okay, 2 ln of y equals negative 3x plus 2 ln of 6 plus 3. Are we okay right now? Remember, I'm solving for y. Divide everything by 2. So now, where do I write it? I got a lot of white space over here. I'm going to write it right here, guys. I'm going to write it right here. So I have ln of y equals negative 3/2 x plus ln of 6 plus 3/2. Are we still okay? How do I get y by itself? E raised to all that. Whatever you do to one side, you do to the other. If your algebra is weak, we will have a hard time. We will talk about logarithms and exponentials soon, guys. Y equals e to the negative 3/2 x plus ln of 6 plus 3/2. I was going to go right into it, but I wanted to. All right. From your algebra days, remember this. Yeah, from your algebra days, if you have e to the m plus n, that means e to the m times e to the n. You guys remember that? Oh. This is your law of exponents. See? X squared times x cubed, that's just x2 plus 3, which is x to the 5th. See how you added there? So as long as you have the same basis, so look what I have. Look, I have that. So I can rewrite this. I just need it for that guy. I'm going to rewrite this like this. Y equals e to the negative 3/2 x plus 3/2 times e to the ln of 6.
So then can't we just say that it's equal to -6?
That's a dot. It's 6.
Or, okay. Yeah, can
Yes, we're there. We're going there, miss. So now I have y equals 6 e to the negative 3 half x plus 3 halves. That is my final equation. We haven't even answered the question. We're about to. We're about to, though. Get up to here. Yeah. 75% of this question is algebra. If we can't do algebra, then we're done. We're cooked. All right. Here's what they want. They want what is f of negative 1. I come back and I say f of negative 1 equals 6e negative 3 halves times negative 1 plus 3 halves. Negative times a negative is a positive, so I have 6e to the 3 halves plus 3 halves. Well, 3 halves plus 3 halves, what's 3 plus 3? And 6 divided by 2? 6e cubed. Is there a 6e cubed in there? That's about as hard as it gets until you get to a class called differential equations, and you'll be doing second order differential equations. You're going to do this, guaranteed, 100%. Stop. Guys, this is not impossible. Look, we're doing it. You just need practice. You just need practice. We're doing it, right? Guys, you guys can do this. There's nothing that can stop you. If you stop yourself, well, then that's on you. So stop stopping yourself. All right, here, let's go to the next one. Yeah, don't stop yourself. Stop stopping. Just keep going. Give the antiderivative of this. So they want the integral of that. It's multiple choice. Which ones are the worst ones? The ln, actually, the ln's the worst one because it assumes that like you just have 1 over something. Do I have a linear expression in the denominator? No, it's quadratic. It can't be an ln. So that's the worst one right there, that one. And this, okay. Yeah, and the bottom one. In BC, when you get to BC, you're going to be doing something called partial fractions. X plus 2 times x minus 9 will not get you x squared plus 4x plus 9. But if it was the correct factors, it could be a possible answer. It's not. It's not on this one. We'll let your Cal 2 professor talk to you about that. Dina will do it next year with Cal BC. What's up? Oh, just hit me up. I'm really bad at returning texts, but I'll return it eventually. I'm really bad. All right, here we go. You guys ready? Here we go. So we know which one of these arctans, and here's what you should know. Guys, real quick. So we should know, well, the derivative of arctan is 1 over 1 plus x squared. Oh, let me put a u here. U squared du dx on the side. Well, that doesn't look like that. I'm going to make it look like that. I just take this 1, and I'm gonna put the 9 over here. 9 plus 4x plus 9. Oh, I don't have that 9 there. 1. X squared plus 4x. Am I okay so far? Okay, here's what I'm going to do with the right-hand side. And I'm going to change my color. I'm going to complete the square with this. With those two. Well, I'm going to have a third term. Chop, why are you doing that? Because I want to have a binomial that I'm going to put a square on it. Does that make sense? Okay, check it out. What is 4 divided by 2? And that number squared, what is that? So I put a plus 4 there. Whatever I do to one side, I got to balance it. So there is no equal sign. So I got to do what to that 9? No, I can't add 4. I already added 4. Minus 4. I don't have an equal sign. I don't have an equal sign, miss. So if I added 4, I got to subtract 4 to make sure it's still the same figure. Yeah, divide by 2 squared. Okay, ask me, Jimmy. Yeah, if our algebra is weak, we're going to have a hard time, guys. What I did was complete the square. Let's talk. You see how I added 4 there? I got to subtract 4 there to make sure this statement is still the same one that I originally started with. See, that 4 and that minus 4 subtract out 0, and I still have x squared plus 4x plus 9. Now, why did you do that? Look, this trinomial here reduces to an x plus 2 with a square on it. Wow. That trinomial there, look. So now I have this. Look, 1 over 5 plus parenthesis x plus 2 with a square on it. See, so you future engineers, you're going to have to be clever with the math because that's how you're going to get to solutions. Yes, you're plenty clever.
Wait, Tom, so then can we just say it's 1/5 plus
Almost.
x plus 2?
Yes, we're not there yet. You're ahead of me. You're way ahead. All right. Now, look, I don't have a 1 in this corner look, that's a 1. I need to have a 1 there. Right now I have a 5. So what do I got to do to get a 5? Divide by 5. Whatever I do to one term, I do to all of them. Like that. So then here's what I have now. So I'm going to write integral. Oh, let me go back to red. Integral. I have a 1/5 in the numerator. I have a 1 plus parenthesis, and I have this. X plus 2 over square root of 5. Close it with a square on it. Dx. Why did I put the square root? Notice I put a square there. I'm dividing by 5, and I put it inside the parenthesis. When I square the square root, I have that 5. Do we see that, guys? Okay. Now look what happens. Let's see if I need that 1/5. I go to the side and I say my u is going to be equal to this linear expression. X plus 2 divided by square root of 5. Let me rewrite it nicer for you guys so you guys can see it. X over square root of 5 plus 2 over square root of 5. I just rewrote it. Look, it's one term. I just rewrote it. du. What's the derivative of x over square root of 5? 1 over square root of 5. It's just a linear expression, guys. Like the derivative of 5x is just 5. The derivative of 2x is 2. The derivative of pi x is just pi. The derivative of 1/5, 1 over square root of 5 with an x on it is just 1 over square root of 5.
So then how would we...
You see this 1/5 here? That is the same thing as 1 over square root of 5 times 1 over square root of 5. Yay or nay? Yeah, see, you got to be kind of good with arithmetic and a little bit of intuition. Yes. So I'm going to have 1 over square root of 5 on the outside. I'm not balancing. That came from here. See? I'm just rewriting it so everyone can see. 1 over square root of 5 over 1 plus x plus 2 over square root of 5. Close it, dx. I'm just balancing it, guys. Making sure everyone can see. Yes.
Okay, so then we can just write it out.
Yes.
Can you explain one more time why you divided by square root of 5?
Well, I divided by 5, not square root of 5. I needed to have a 1 on this upper left-hand corner because I know my derivative of arctan is have a 1 there. So I said, well, I already have a 5 there, so divide by 5, divide by 5, divide by 5. And then I said, okay, well, there's my 1/5. 1 plus, look, I put a square on it. So there's my 5. Square root of 5 times square root of 5 is 5. Right now, right here was outside of those parentheses with the square. Now it's inside the parentheses with the square. See? So, and then I just did my du substitution. du was 1 over square root of 5. So I forced it. 1 over square root of 5 times 1 over square root of 5 is 1/5. 1 over square root of 5, one of those goes on the outside of the integral. And one of those stays on the inside. And then 1 over square root of 5 with a dx on the side. There it is. I substituted that, and that's my du.
So then which word is we?
So here it is. No, I haven't missed. You're 2 ahead. 1 over square root of 5 integral 1 over 1 plus u squared du. Because all that right there, that was du. Do you guys see that? And now I have 1 over square root of 5 arctan of u plus c.
And since we don't have limits, it would just plug back in. So it'd be 1 over square root of arctan of x plus 2 over square root of 5.
Yes. Sometimes they rationalize it. UH hasn't been rationalizing it, but sometimes they do.
So you're going to put this like x plus 2 square root of 5 over 5 and then square root of 5 over 5.
Yeah.
Right.
That's about as hard as it gets. It does not get harder than that. How do we feel? All right, guys. All we got to do now is practice. I put some long division problems on delta. I think they might call it synthetic division. No, they think they call it long. And then make sure you take care of the UH. And that's it.